So I think it's safe to say the era of the chatbot is, well, it's officially over.
Oh, completely over.
Yeah, we are no longer just talking to, like, smart typewriters. We're actually hiring autonomous digital workers now, which is wild. So welcome to the deep dive, everyone.
Thanks for having me.
Of course. For the last few years, whenever anyone brought up AI, it felt like we were all just sort of marveling at a parlor trick.
Right, like a really impressive magic trick, but still a trick.
Exactly. You type a prompt into a little text box, it types back a poem or, a recipe for banana bread or an email draft. It was basically a super-powered encyclopedia, and it just waited patiently for your next command.
Yeah, and I mean, think about how limiting that call and response system actually was in practice.
It's very passive.
Right, it's totally passive.
Yeah.
You ask, it answers, and then it just, sits there completely frozen until a human decides to step in and intervene again.
Just waiting around.
Yeah, but what we're looking at in our sources today is a total fundamental departure from that model. We are stepping into the era of what's called agentic AI.
Agentic AI.
Yes, so instead of a passive tool, we're talking about active autonomous agents. These are systems that observe a problem, reason through the steps needed to solve it, formulate a long-term plan, and then, here's the key, they execute those tasks completely independently.
And the ripple effects of that shift, they are monumental. So our mission today for you listening is to really unpack this massive industry-shifting presentation we've got in front of us. It's NVIDIA's 2026 GTC Taipei Keynote, delivered by CEO Jensen Huang.
And what a keynote it was.
Oh, yeah. Now, on the surface, sure, this was a multi-hour technology showcase, lots of hardware. But as we dig into the research, the data points, the market analysis surrounding it, it becomes incredibly clear that this wasn't just a tech demo.
Not at all.
It was basically an advanced masterclass on the future economics of the entire tech industry.
Yeah, it's really about how the basic unit of AI computation, which we call a token, has transformed.
Right.
It's gone from being this cool novelty to pure measurable revenue, like hard cash. And this shift is actively reshaping global GDP right now. You see it dominating every major corporate earnings call.
The financial implications are just staggering to look at, and because we're talking about these massive shifts in corporate valuations, computing economics, and global GDP today, I do need to give a quick reminder for you listening. Yale Town is... So to be clear, we are analyzing the underlying tech and the market mechanics here.
Right. We are definitely not picking stocks today.
Exactly. So to really understand these massive new hardware factories that NVIDIA is building, I feel like we first have to understand what they are actually manufacturing, right?
We do. We have to start with the software because, you really can't grasp the scale of a $50 billion hardware investment without understanding the product that's rolling off that assembly line.
Makes sense. And what are they manufacturing?
They are manufacturing tokens for agentic AI.
Okay, so let's draw a clear line in the sand here for everyone. I think everyone listening is pretty familiar with large language models, or LLMs.
Right, the brains behind the classic chatbots.
Yeah, the brains. But an agent is something entirely different, isn't it?
It really is. So an agent uses that large language model, but strictly as its reasoning engine. The LLM is just the brain.
Just the brand, okay.
Right. And an agent is that brain placed inside what developers call a harness.
A harness.
Yeah, it's like a software shell that surrounds the neural network and gives it crucial new abilities. So it gives it short-term working memory to, track its current progress on a task.
Like keeping its place in a book.
Exactly. And long-term memory to remember past interactions. But most importantly, the harness gives it the ability to use external tools.
Okay, so instead of just generating a block of text about, I don't know, how to make a spreadsheet, the agent actually has the digital hands to open Microsoft Excel itself.
Yes. It can populate the cells, format the columns, save the file. It observes a problem, reasons about the optimal path forward, and then uses whatever tools it needs. A web browser, a Python compiler, a database query. It acts on the plan.
Wow. I picture it like the evolution of the workplace. Like we've moved from having a really smart reference book sitting on our desk.
Right, the old chatbot.
Yeah, to having an army of highly capable digital interns. And, you don't ask an intern a trivia question. You give them an objective.
Exactly. You give them a goal.
You say, go research this emerging market, pull the financial data into a spreadsheet, cross-reference it for errors. and email me a synthesized report by Tuesday. And they
Okay.
just go do it in the background while you focus on something else.
That's the perfect analogy.
Yeah.
Now, take that army of digital interns and apply it to the entire global workforce.
Oh, man.
The economic output just goes completely parabolic. And the keynote actually provided a deeply analytical look at this through GitHub.
Right, the platform where software developers write and test their code.
Exactly. And the metrics coming out of GitHub right now are just wild.
They are. I saw the numbers. So in 2023, the platform recorded roughly 300 million code commits. And a commit is basically a developer saving a finalized piece of work, right?
Not a finished chunk of code.
But by the first few months of 2026, the pace of those commits has nearly tripled.
Tripled. And we really need to look at the mechanics of how that tripling happened. Because it isn't just that humans are suddenly typing 3 times faster.
Obviously.
No. It's because human developers are managing agents. So a human writes a prompt outlining a new software feature. The agent takes over, writes the base code, automatically runs a testing protocol, spots its own bugs, goes back to rewrite the broken functions, retests it.
It's doing all the tedious stuff.
All of it. And then it just presents the finished feature to the human for approval. The agent is doing the grueling, iterative labor in literal seconds.
And scaling that up to a macroeconomic level, I mean, that's where the GDP numbers start to look like science fiction to me. Because there are roughly, 30 to 40 million software engineers globally?
Yeah, somewhere in that range.
And collectively, they earn about $3 trillion in salaries. Historically, that $3 trillion investment by companies generates an enormous chunk of the world's technological GDP. But now, because these agents are handling the iterative coding, that exact same human workforce is producing nearly 3 times the output.
Right.
We're looking at $9 trillion worth of productivity flowing from a $3 trillion salary base.
It's a massive wealth creation event.
But wait, I do have to challenge the economics on this a bit. Because
Yeah.
if I run a company, right, and my digital interns suddenly allow my developers to produce 3 times as much code, logic dictates I just don't need all these developers anymore.
You think so, right?
Yeah. Wouldn't the immediate corporate response be to fire 2/3 of the workforce to maximize profit margins? I mean, save the cash.
It seems like the obvious corporate playbook. But the labor data and the recent earnings call transcripts we reviewed, they completely invalidate that assumption.
Wait, really?
Yeah. The demand for software engineers is actually climbing sharply.
Why? I mean, if you have autonomous agents doing all the heavy lifting, why hire more humans?
Because software is not a finite resource. It's not like building a bridge.
How do you mean?
Well, with a bridge, once it's built, you send the construction crew home. The job is done. But in the digital economy, there's infinite demand for better software. So if an engineer traditionally generated $100,000 of value, and now, armed with a team of agents, they generate $300,000 of value, your profit margins per employee just explode.
Oh, I see.
Right. So companies don't want to shrink a hyper-profitable department. They want to hire more engineers to manage more agents to capture even more market share.
That is fascinating.
It flips the oldest rule in the tech industry. Historically, computing power was a cost center. It was an expense on the balance sheet. You tried to minimize it. Today, compute is revenue. Every token generated by an AI agent is a profitable unit of work.
Compute is revenue. That is a massive conceptual leap. And if computing power is literally minting profitable output, you cannot run a $9 trillion economy on a server rack from 2023.
Definitely not.
Which brings us to the physical infrastructure. Because these tokens are generating hard revenue, companies are radically changing their capital expenditure strategies, aren't they?
Completely. They are no longer buying computers. They are building AI factories.
AI factories. And the scale of these facilities, I mean, it defies traditional IT architecture. We are talking about $50 billion to $100 billion capital investments.
For a single facility.
For one facility. And they consume a full gigawatt of power. To put that in perspective for you listening, a gigawatt is the output of a nuclear reactor. It is enough energy to power a medium-sized city.
Yeah, and inside these gigawatt factories sits NVIDIA's new supercomputer, the Vera Rubin system.
Right, which completely replaces the Grace Blackwell architecture.
Yes. And looking at the engineering schematics for Vera Rubin, it sounds less like a computer and more like, I don't know, an alien artifact.
It really does. It's a multi-rack pod-scale system. It utilizes hot liquid cooling. And the craziest detail to me, there are virtually 0 cables connecting the core components.
0 cables.
Yeah. It's all routed through these extreme density circuit boards, which they built through a massive collaboration of, I think, 150 different supply chain partners across Taiwan.
Let's break down why they engineered it that way. Because the zero cables detail, it isn't just some aesthetic choice. It is a strict physics necessity.
Oh, really? Why is that?
Well, copper cables create electrical resistance. When data travels through a physical wire, that resistance generates heat.
Right, basic physics.
Heat wastes electricity.
Yeah.
And worse, it forces you to use even more electricity to cool the system down.
So every watt of power you spend pushing data through a cable or running an air conditioner to cool that cable down is a watt you cannot use to run the AI itself.
Precisely. And remember the core financial metric driving this entire industry right now. Tokens per watt. If your new factory is strictly capped at 1 gigawatt of power from the local grid, you cannot cheat the math. You can't just plug in more machines.
Your power budget is your power budget.
Exactly. Your only path to increasing revenue is extracting more AI output out of every single electron.
Wow.
So by eliminating the cables and using these ultra-dense pod-scale circuit boards, meaning they basically treat an entire room of servers as one massive continuous motherboard, the electrons travel microscopic distances. They strip out the resistance, they strip out the heat, and they pour all that saved power directly into token generation.
Okay, that perfectly explains the massive physical overhaul. But there is a specific hardware shift happening inside these racks that I really want to dissect.
Let's do it.
Because for the last 5 years, the entire AI revolution has been totally synonymous with GPUs, graphics processing units.
Right, the workhorses.
But in this keynote, NVIDIA pivoted hard. They spent a massive amount of stage time hyping up their reinvention of the CPU, the central processing unit, which they named the Vera chip.
The Vera CPU. Yeah.
So if GPUs are the engines of AI, why is the CPU suddenly the star of the show?
This goes right back to the difference between old chatbot AI and new agentic AI. Let's use an analogy. Imagine the GPU as a massive, incredibly powerful symphony orchestra. It has thousands of musicians and can play 1 million notes simultaneously.
Okay, I'm with you.
The CPU, on the other hand, is the conductor.
Oh, I like this. So in the old chatbot model, the conductor just hands the sheet music to the orchestra, steps back, and lets them blast through the symphony. The GPU does all the heavy lifting to generate the text response.
Yes. But agents behave very differently. Agents do not just play a continuous song. They constantly pause to think.
Oh, because they're reasoning.
Exactly. They stop to check their working memory. They pause to open a web browser. They run a quick Python script to verify a calculation. Every single time the agent needs to use a tool or access its software harness, it interrupts the orchestra to ask the conductor a question.
And if the CPU takes even a fraction of a second to answer, that massive multi-billion-dollar GPU orchestra just sits there in total silence.
Yes. And an idle GPU is not generating tokens. If it's not generating tokens, it is not generating revenue. And your multi-billion-dollar factory is bleeding money.
That makes total sense.
Traditional CPUs were engineered for humans. You know, if a database query or a web page takes half a second to load, a human user really doesn't care. A human operates in seconds.
But agents are impatient. They operate in nanoseconds.
Exactly. Agents need instantaneous answers. That is why the Vera CPU was engineered specifically to break this bottleneck. It operates with a profoundly high IPC, which stands for instructions per clock.
Okay, let's assume I don't have a degree in computer engineering. What does a high IPC actually mean in the context of our orchestra analogy?
IPC is essentially how fast the conductor can read and process the sheet music. So the Vera CPU can read and execute 10 instructions per single clock cycle, while simultaneously using massive memory bandwidth to shuffle data back and forth to the GPU instantly. Right. By making the CPU blindingly fast, Vera ensures the GPU never has to wait. The orchestra plays continuously, the tokens keep flowing, and the gigawatt factory hits its revenue targets.
Man, the engineering required to solve that latency issue is just brilliant. The CPU is basically no longer a general-purpose processor. It is a hyper-specialized traffic cop for autonomous agents.
Exactly.
So we've established how these agents are conquering the massive cloud data centers. But looking at your laptop right now, or, the phone in your pocket, the paradigm shift is just as radical. The keynote made it explicitly clear that agentic AI is not just a cloud phenomenon.
Far from it. Microsoft and NVIDIA are framing this as the most significant disruption to personal computing since the launch of Windows 95.
That's a huge claim.
They are fundamentally tearing down the concept of the PC and rebuilding it.
Right. They unveiled a new architecture called RTX Spark. It's a specialized laptop and desktop chip that fuses an NVIDIA GPU with a custom-designed MediaTek CPU.
Yeah, that partnership is key.
But the hardware is really only half the story here. It runs a completely new kind of operating system where the large language model acts as the foundational layer of the machine. It actually reminded me of DirectX.
That is a highly accurate comparison. I mean, for anyone who games on a PC, DirectX is the invisible underlying software that translates the game's code into instructions your graphics card can actually understand to render the visuals.
Right. You never really see it, but it's doing the translation.
Right, and in this new agentic operating system, the AI model is the underlying translation layer. It sits between you and the machine, translating your high-level intentions into thousands of micro-actions across your applications.
And the keynote demonstrated this with just a breathtaking example in architecture and 3D design.
Oh, the Rhino demo.
Yes. So you sit down at your RTX Spark laptop, you don't open any programs, you just give your local agent a prompt. Maybe you drop in a few concept sketches and some text describing a modern house on a sloped hill.
And then you just walk away.
You literally walk away. The agent autonomously opens a complex 3D modeling program called Rhino right there on your local machine. It drafts the terrain, it builds the load-bearing walls, and here's where it gets staggering to me. It runs a local physics simulation, detects that the roof support is structurally flawed, deletes the bad geometry, redesigns the support beams, ports the entire project into Blender, and uses generative AI to render photorealistic lighting.
All locally.
Yeah.
And we really must talk about the economics of running that workflow locally. Because NVIDIA released a new open-source software model called Neotron 3 Ultra to fuel this hardware.
Okay.
It's 5 times faster and 30% more efficient, and it's built exclusively for these local agents. Because this entire drafting process happened natively on your RTX Spark machine, you avoid what the industry calls meter anxiety.
Meter anxiety, like leaving the meter running in a taxi.
Exactly. When you run complex agents in the cloud, you are basically watching a digital taxi meter tick upward with every single token generated. If your agent makes a mistake and has to recalculate, you pay for it. It gets prohibitively expensive.
But on your local device, your marginal cost is zero.
Zero. You own the hardware, you pay for the electricity from your wall outlet, and that is it. The traditional computing interface, where a machine just sits dumbly waiting for you to click a mouse and type on a keyboard, that's obsolete.
It's totally dead.
Your new desktop is a tireless entity that runs 24/7. It can manage your personal finances, conduct deep academic research, or grind through massive video rendering workflows all night long autonomously.
Think about the trajectory of the smartphone. Like 15 years ago, a mobile phone was a device you used strictly to make phone calls.
Right.
Today, the device in your pocket does literally everything but make phone calls. It is your bank, your map, your television, your camera. It completely redefined what the object even was.
And the personal computer is undergoing that exact metamorphosis right now. It is transitioning from a static digital toolbox into an active, autonomous sidekick.
It's like having an incredibly competent digital co-pilot permanently stationed on your desk. But, as transformative as that is, agents eventually have to step out of the screen, right?
They do.
They have conquered the data center. They are conquering the laptop. But the final frontier discussed in the keynote is the physical world. Physical AI and robotics. Now, I have to admit, I always harbored a pretty naive assumption here.
What's that?
Well, if an AI can pass the bar exam, write flawless Python code, and generate a photorealistic movie from scratch, I assumed programming a robot to simply fold my laundry or navigate a busy sidewalk would be trivial.
Yeah. That is actually a famous concept in computer science. It's called Moravec's paradox.
Moravec's paradox.
Yeah, it states that high-level reasoning requires very little computation, but low-level sensory-motor skills require enormous computational power. So folding laundry is exponentially harder than passing the bar exam.
That's crazy to think about.
It is, and it all comes down to a massive deficit in data.
Because the AI doesn't know what a shirt actually feels like.
Exactly. Think about how we trained large language models. We scraped all the text on the internet, Wikipedia, books, news articles. But human text is based on human logic.
Right.
To train a physical robot, you don't need text. You need physical, spatial data. You need a first-person understanding of how joints articulate, the precise torque required to lift a cup without crushing it, how gravity affects a falling object, the friction of different floor surfaces.
You can't learn gravity by reading Wikipedia.
No. And you can't scrape that data from YouTube videos either. Because a 2D video doesn't contain physical force measurements. There is no Wikipedia of robot joint movements.
Wow. So if the spatial, physical data doesn't exist, how do you train the brain of a robot?
You have to hallucinate the data.
Wait, hallucinate it?
You have to invent it from scratch. And this is the profound breakthrough behind NVIDIA's Cosmos 3, which they call a world foundation model. Their new engineering philosophy is simply, compute is data.
Meaning they use the supercomputers to simulate reality?
Yes, they create perfectly accurate digital twins of the real world. Cosmos 3 generates physics-accurate synthetic arenas. It is essentially a hyper-realistic video game matrix where the physics engine is flawless.
Like the Matrix.
Very much like the Matrix. Inside this simulation, digital robots can practice walking, falling over, adjusting their balance, and learning from millions of failures at the speed of light. They master the physics in the digital matrix before that software brain is ever downloaded into a physical metal chassis.
The idea that we are utilizing massive data centers to dream up synthetic realities to teach machines how to walk is just incredible. And the keynote proved this isn't just theory anymore. They showcase Elpimo 2, which is a self-driving vehicle model trained on this synthetic data, and it's currently integrated into 80% of car brands via the Hyperion system.
Yeah, Elpimo 2 is amazing.
What fascinated me most about it was how it processes the environment. It essentially possesses an internal monologue. It is literally thinking out loud to navigate traffic. The diagnostic readouts show it saying to itself, pedestrian approaching crosswalk, applying brake pressure, delivery van stopped in the right lane, calculating trajectory to nudge left.
It is observing the physical environment, reasoning through the variables, planning a safe route, and then acting on the steering wheel. That reasoning layer is the defining characteristic of agentic AI.
It's the exact same loop.
It is. The underlying computing pattern is identical across the board, whether it is an agent writing software in a gigawatt cloud factory, an agent drafting a 3D house on an RTX Spark laptop, or an Elpimo 2 agent navigating a busy intersection. It is the exact same autonomous loop.
The brain operates on the exact same logic. It just wears a different body.
Well said. And to standardize those bodies, NVIDIA introduced Isaac Groot.
Right.
This is a 6-foot, 150-pound reference humanoid robot. It features 25 degrees of freedom in its hands alone.
Just the hands.
Just the hands. And by open sourcing a standard hardware reference, roboticists no longer have to waste years building custom metal joints from scratch. They can adopt the Isaac Groot chassis, plug in a Cosmos 3 simulated brain, and immediately begin training that robot to work on factory floors or assist in hospitals.
The sheer volume of innovation here is overwhelming. So let's try to synthesize the massive ground we've covered today. This wasn't just a product launch. It really was the blueprint for the next decade of the global economy.
Absolutely.
We explored the software revolution, where agentic AI is transforming computing power directly into highly profitable digital labor, radically spiking developer output.
Right, and because that output is so lucrative, the physical infrastructure of the internet is being completely dismantled and rebuilt to eliminate latency.
Which gives us that extreme engineering. The pod-scale liquid cooling, the zero-cable architecture, and the Vera CPU to keep the GPU orchestras playing seamlessly. We looked at how that immense agentic intelligence is being compressed to run local on your desk, with RTX Spark turning the traditional PC into a tireless, autonomous sidekick operating without any meter anxiety.
And finally, we saw how those agents are breaking out of the digital realm and stepping into the physical world. Trained inside the flawless physics simulations of Cosmos 3 and housed in standardized humanoid frames like Isaac Groot.
It is a total top-to-bottom reinvention of the technology stack. But looking closely at the forward-looking statements in these earnings calls and keynotes, this transition carries immense execution risk, doesn't it?
Oh, the risk profile is astronomical.
Right.
We are stepping into an era of building 100-gigawatt AI factories. The capital expenditures required are in the hundreds of billions of dollars per company.
Staggering sums of money.
And when you're drawing that much power from local grids and routing hot liquid cooling through ultra-dense server racks, there is absolutely zero margin for error. You cannot afford to pour $100 billion into a facility only to realize the thermal dynamics of your building are slightly off, causing the chips to literally melt.
That would be catastrophic.
Which is why every single one of these factories must be perfectly simulated as a digital twin inside NVIDIA's Omniverse before a single physical brick is laid or a single trench is dug. The survival of the physical tech industry is now entirely dependent on flawless digital simulation.
It completely reframes how you look at the entire digital world. We started this deep dive acknowledging that the chatbot is dead, replaced by autonomous digital workers. But I want to leave you listening with a final thought to mull over as you close your laptop or look at your phone today. If the device sitting in front of you right now has an autonomous reasoning agent, and the corporation you work for is deploying armies of cloud agents, and the car you drive is piloted by a navigational agent,
Wow.
what happens to the fabric of our daily lives when these digital entities stop waiting for our prompts and start negotiating, planning, and executing tasks directly with each other at nanosecond speeds?